Hi friends, given question is let f is mapping from R to R and g is mapping from R to R be two functions and defined by f of x is one function log x square plus 1 minus e power minus x plus 1 and g of x is equals to 1 minus 2 into e power 2x by e power x. Then for which of the following range of alpha inequality given condition f of g of alpha minus 1 whole square by 3 is greater than f of g of alpha minus 5 by 3 wholes. Which option is correct? Okay, now in this equation, in this question solving method, here condition is there, here two function f is function is there, g function is there. Here now in one of the condition is there, here for example x1 is greater than x2. Okay, x1 is greater than x2, function is increasing, therefore f of x1 is greater than f of x2. I am taking function f of x1, f is function. Okay, this is the condition, x1 is greater than, function is increasing, so f of x1 is greater than f of x2. For example x1 is greater than x2, for example function is decreasing. Okay, now function is decreasing, that condition f of x1 is interchange f of x2. Okay, increasing condition, x1 is greater than x2, this function is increasing, f of x1 is greater than f of x2. For example function is decreasing, x1 greater than x2, then function is decreasing, f of x1 is less than f of x2, means this inequality is change and interchange. Now this condition is, what is the given condition? F of x is the one function. Okay, now log x square plus 1 minus e power minus x plus 1. Function increasing and decreasing, how to find? First derivative. Okay, f dash of x, function is derivative, f dash of x is greater than 0, this function is increasing, function f dash of x is less than 0, function is decreasing. Now in this case 1 by d by dx of log x means 1 by 1 plus x square. Now here internal derivative 2x, here also same, minus e power d by dx of e power x. E power x means e power x internal derivative minus 1, here d by dx of constant means 0. Now f dash of x is equals to 2x by 1 plus x square minus of minus plus e power x. Okay, here now in this case f dash of x, e power x is always positive. Now this value is also positive. How? This is numerator x is there, here 1 by x square. For example x plus, in place of x is equals to 2 is substitute, 2 means 4 by 1 plus x square. Okay, 1 plus x square means 1 plus, in place of 2 substitute x plus x, in place of x is 2 is substitute 4 plus 1 means 5, 4 by 5 means something 0 point something like that. Here expansion, if this expansion value always positive na, means this value always decreasing, means value decreasing, this value always decreasing function, so this is expansion increasing, this is always minimum value is 2.7 like that. Here value is, minimum value is, here for example x is equals to 0 substitute, the minimum value is 0, so totally value is, here value 1, in place of x is equals to 1, 1 by 1 means 2, 2 by 1 plus 1 means 2 by 2 means 1. Here for example 2 substitute, this value is minimum between the 0 to 1. Here in case any value is substitute in between the 0 to 1, here always decreasing, here always this function is always increasing. Now this function is always what? Increasing function, so this value always is positive, so f dash of x is greater than 0, f of x is always increasing function. Now g of x function, g of x is equals to 1 minus 2 into e power 2x by e power x. Again derivative, g dash of x is equals to u by v method, e power 2x, e power u by v method, d by dx of u by v is equals to v square v u dash minus u v dash. V u dash means d by dx of constant is 0. This what 4 into e power 2x. Here minus u means 1 minus 2 into e power 2x into v dash means d by dx of e power x means e power x. G dash of x is equals to minus 4 into e power 3x. Here 1 into e power x minus into minus plus 2 into e power 3x by e power 2x. In this case simplification. Now how? Minus 4 minus 2 e power 3x minus e power x by e power x, e power 2x. In this common, minus e power x is common. What? 2 into e power 2x plus 1 by e power 2x. This one time cancel, minus 2 into e power 2x plus 1 by this e power x. This is always positive. Now this is also always positive. Positive into negative, negative. So this value is decreasing. G of x is decreasing function. Now here what is the given condition? F of g of alpha minus 1 whole square by 3 is greater than f of g of alpha minus 5 by 3. Now here f is increasing function. F is increasing function means f of x1 is greater than f of x2. We can write as x1 is greater than x2. Now f of x1 is greater than f of x2 means f of alpha minus 1 by 3 is greater than g of alpha minus 5 by 3. I am taking, just imagine, sometimes x1, this is x2, f of x1, f of x2. We can write as x1 is greater than x2. Increasing condition. Now here g is a decreasing function. G is decreasing. Decreasing means x1 is greater than x2. Now we can write, for example, f of x1 is less than f of x2. We can write as x1 is greater than x2. For example, interchange means here is greater than is there. Now alpha minus whole square is here interchange means alpha minus 5 by 3. This we can write as what? A minus b whole square, a square plus b square minus 2 alpha by 3 is less than 3 alpha minus 5 by 3. This 3 is cancelled, remaining what? Alpha square plus 1 minus 2 alpha, this sent to this, minus 3 alpha plus 5 is less than 0. Now alpha square how much? Minus 5 alpha means 6 is less than 0. These factors is alpha minus 3, alpha minus 2 is less than 0. Now this is, we can write as here what? Alpha minus 2 into alpha minus 3 is less than 0. Now we can take Vevika method. 2, 3. Start with plus. Plus will be here odd power means plus will be minus, minus will be plus. Now this is negative region. Negative region we have to take, means alpha belongs to 2 comma 3 open interval. Okay, in case, for example, options in closed interval, we can take greater than or equal to. Okay, sorry.